want to thank you all for coming here on the last day of the ARC Forum. So this session is entitled The Future of the Industrial Edge. I'm Patrick Arnold, analyst at ARC, and I wanted to welcome you all here today. On the agenda, I'm going to give a quick introduction here and then share with you some ARC data from our yearly survey. And then we're going to have some end-user presentations talking about some of the ideas here and putting them into practice. And at the end, we're going to have a Q&A discussion with our panelists. So I want to encourage you guys to get your questions ready, of course. Just a few reminders for the event. I'm sure you've seen something like this before. Just make sure to silence those devices. We want to give our attention and respect to the people who are coming here today to present. And get ready with those questions in advance for our Q&A panel. And of course, we are always trying to make the ARC Forum better every year. So if you've got feedback, place that feedback in the app or reach out to us directly. We love to hear it. We love to see how we can make it better every year. So what is this Edge session all about? It's really when you have this pervasive compute power and connectivity intersecting with internet-enabled portions of the infrastructure, you can do some really interesting things. You can create a solid data foundation for your organization's strategies for data acquisition and even AI looking into the future. You can enable connected products and services. And you can utilize suitable IT technologies in an OT environment, just the good ideas. And you can gain some flexibility in how you're deploying your processes when things aren't locked into certain hardware. So just a little bit of ARC data here. We don't have to dwell too long on this one, but this is looking at where people are planning to implement edge computing in terms of what hardware platform they're using. So at the top here, it's a pretty big number for network infrastructure. And compared to previous surveys, this number has gone up across the board. So really we're seeing the recognition of edge computing, as a more, mature idea. And it's pretty interesting. We've got the usual suspects, gateways and IPCs, but really the takeaways here is that this compute power is everywhere. The modern devices are becoming more capable and computing power is becoming a lot cheaper than it was in the past. So how can you really utilize these new technologies and this new hardware capability? And when you have that, the question is, how much can you do in the industrial edge environment and how much goes to the cloud or some other centralized area? If you operate on this classic model of sending everything to the cloud or an excessively centralized architecture, that can be expensive to operate sometimes. And if you're moving into a more edge-related strategy, sometimes there's unfamiliar tools and a unique landscape. Every operation is different. And I'm sure there's lots of startups and things that are offering different tools to sort through. But really, it's all about can we grapple with these new ideas with the reality of industry, which is sometimes it's a unique environment with unique needs, and you don't always have that consistent connection. So here's some more ARC data from our big survey. This survey contained a mix of all verticals. Mostly decision makers, but a mix of roles as well. And this one we have the benefit of asking this question in a previous year, so we can really see the changes year over year. And the biggest mover up here we see is that security is one of the leading applications for running on the edge. And it had a big bump up from last year. It really just goes to show you that, the security is still a huge topic. And when it comes to the industrial edge and IoT, people are really looking for ways to reduce the risk, protect their investment, and find new ways to be secure. And we also see some big increases from last year in the analytics and AI and ML category, which goes to show that people are using more sophisticated applications on the edge. It's less of the lower level protocol conversion that we saw in the past. And then another interesting one, plus 7% in virtualized and soft control. These are These are technologies that are developing, and I think there's a lot of interest in how we can make use of these going forward. So just some more takeaways from that. Obviously, security is a major focus, and you're seeing more of these, security applications being run, like firewalls, network monitors. These are more part of the greater value of the industrial edge. And of course, a data strategy is paramount. And the data pre-processing, this has long been, a pretty stable value proposition for the edge. Cleaning data, making it suitable for consumption, reducing the size so you don't have to, spend a bunch of money sending that data around. It's just becomes more cost effective that way. And I think people are still looking to analytics and AI as ways to really get a tangible return on investment for edge computing. We've really seen, from an initial focus on those sort of lower level applications, it's really getting more sophisticated and people are doing some interesting things. And it's all about turning that data that you're able to access now into something that can give you business value. So the question here is asking, where are you interested in applying your AI and on the industrial edge? So obviously, I think the first thing you might notice here is that, the smartphones is the top one here. And I think that just goes to show you that, these devices are becoming more capable. And you might not think of a smartphone as, a ruggedized industrial device. It's not. But a lot of people are looking to that as a way to supplement the automation environment. And as we see that hardware capability is increasing and people are trying to, figure out how to use AI at the edge, they're experimenting with a lot of different platforms and seeing what they can do. So we've also got controllers as a high one here, AI PCs, and cameras, of course. And I think it really speaks to the edge as a foundational data source for AI. So you have this traditional model of you collect the data, you send it to the cloud, you train a model, you make an inference, and then send it back to your operations. But really, if you're able to fully utilize the industrial edge, you can really make use of these machine learning models for real-time inferences, where you have the reciprocal relationship between the edge and wherever your data is going, where you can collect that data, train the model where you have more compute power in a centralized location, and then deploy that machine learning model back onto the edge device so that you can make an inference right there in a low latency environment and save more money when you have to transfer data back and forth. And just a few growing and emerging use cases that we've seen. Computer vision is really interesting right now. We're seeing the use cases for quality control, safety monitoring, visual inspection. These things have been theoretical for a while and in practice for a few years, but we're starting to see a lot more mature offerings in these cases. And we're also starting to see, people are using machine learning and AI for optimization. They're really, adjusting processes on the fly, starting to utilize the promise of predictive maintenance and, really using these models to fine tune how we can better consume our energy and manage our emissions. So here's another one I wanted to throw in here. This one's looking at, it's 2030, so it's a future timeline, but how widely do you expect to be using virtualized PLC and DCS controllers? So I know this is something that has been in development for a while now, but I think it's pretty promising here that we've got pretty high numbers, more than 50% people plan to be using them in some instances, a pretty significant amount. So I think we're going to see going forward that people are really going to look into virtualized PLC and DCS controllers and see what they can do. So just some takeaways here on the virtualized side of things. One of the main benefits for virtualization in general is you can consolidate your workloads into a single device instead of having a dedicated hardware for every single process that you have. And you can also spread the compute power around and distribute your applications to where you have that edge compute in different locations. So these models can make your application strategies more scalable. It can move from this inflexible hardware-centric model to a more flexible software-defined model. And just some things to consider that people are looking to solve now. The management complexity obviously can be a pretty big issue, and there are plenty of orchestration and application management tools looking to solve that problem. And it's also a unique cybersecurity environment. So some of the legacy tools that you have in place might not have full visibility into these new technologies. And of course, you always have resource constraints at the edge. So what's the right technologies with the right management overhead that you can utilize? Just a few recommendations here from our ARC research. You can leverage the cloud, but maintain a secure and reliable edge. So you want to take advantage of the cloud benefits where you can, and you can even take that cloud experience to the edge, sometimes with a lot of the products on the market now. And you can power your data initiatives with that resilient connectivity and edge compute, keeping things on the edge when they benefit from being on the edge. And you should also evaluate the opportunity to consolidate workloads in a virtualized environment, because we see the trends in the ARC data that you need to be prepared for the eventuality of a more software-centric future when it comes to industrial automation. And really consider how avoiding vendor lock-in, maintaining secure interoperability, and future-proofing can be valuable. There's the buy versus build equation when it comes to edge applications. You can help build internally to really suit the exact needs of your organization, but the supplier ecosystems for off-the-shelf applications are growing pretty rapidly. And this can, if you have less dedicated developer or IT resources at your organization, it can save on training and development time. And then, of course, ARC data shows that the organizations that are best meeting their digital transformation goals are the ones that have IT, OT, and sometimes ET all collaborating. They're all at the table together making decisions. And true IT-OT convergence might not be the reality for many people, but you still need an organized plan to get on the same page if you want to utilize new technology. And I just wanted to highlight a little bit of what ARC's got going on right now. Ongoing research, we've got edge computing, IoT platforms, 5G, a lot more as well. And then some new priorities for us in 2025. We are going to be taking a look at virtualized automation and see what's going on there. We're also going to be looking closer at how exactly people are using AI on the edge, the exact use cases and how that technology is progressing, and also how low-code and no-code platforms can help the software development experience when it comes to industrial environments. And of course, we're looking at all of the open standards organizations that are growing in momentum right now.